Hi everyone, this video is the first of the analytical chemistry series for education students. So, do you have any idea what analytical chemistry is? So actually class, analytical chemistry is a quantitative science. It means no. So in analytical chem, we ask questions such um, how much glucose is there in the human blood, or how much chlorine is there in our drinking water. So analytical chemistry tries to answer these questions. So what analytical chemistry can do to answer those questions is that, for example, in the detection of glucose present in the blood, it should be able to, of course, detect, right? The analytical chemistry detects the presence of the analyte, for example, the glucose. And then analytical chemistry answers also could identify. Okay, so aside from detecting, it has to identify that that substance is indeed glucose, and then it is also able to quantify the amount of glucose. So it answers numeric value of the amount of glucose, and then it could also separate a specific analyte from other components. And in modern analytical chemistry class, it also includes rather to optimize or to improve methods and instruments. So for example, before in the analysis of gold in ancient times, we only use the fire assay technique. Actually, I've worked at a mining company before, and mining companies still use the fire assay technique. But the downside of this technique is that it could only analyze samples which have high amounts of gold. So from what I remember, it's almost 1 gram, like almost 1 gram. That's per 50 grams of ore of the sample. So that's too big, right? So if it's maybe half of a gram, like 500 milligrams or lesser, it won't be able to detect the presence of gold. So the analyst would report that there was no gold found, or no gold is present in the ore, which is not really true. The truth is that the fire assay technique, this method could just could not analyze low amounts of gold, could not detect low amounts of gold in a sample. So in modern analytical chemistry, now we already have AAS or ICP. This could analyze gold even up to 0.001 ppm. So which is quite small. Okay, so how do we move this one? Okay, so as I've mentioned, analytical chemistry is a quantitative science. Now, we ask questions like, is this water safe to drink, right? Or does the emission testing of automobiles reduce air pollution? Now, these questions, when you ask so these questions are asked by the public, right? Like, is this water safe to drink? This is like a general public question. But a scientist would translate this, a scientist, especially an analytical chemist, chooses to translate this has to translate these questions into the need for particular measurements. So we have to answer these questions with data. And so an analytical chemist would invent a procedure or method in order to answer those questions. So in order to carry out the measurements that could answer the questions. Okay? So when the analysis is complete, so we have, okay, so an analytical chemist would invent method, right? So we would make method, and then when the analysis, we would get results, right? Now, when the results are complete, this has to be translated to the general public, because these results only the analytical chemist could understand. Not really, but only the scientific, probably scientific. This could not be understood by the general public. So the analytical chemist or the scientist has to translate these results, in order for the general public to understand. Right? So in every measurement class, in every measurement, in every measurement, there is some error. Nandiyan na error. Okay? Now, in order for this to be translated to the general public, you have to state the limitations. Like, what is the statistical uncertainty in these reported measurements, in these reported results? How reliable are these results? So if I took the sample in a general, in a different manner, would I have obtained the same results? Do you understand? Okay. So in for example, in an analysis of a food material, so for example, I'm working in a food industry, and so we have to analyze food materials, right? So the first thing that we have to do is to plan. So planning is a very crucial step. So we have to identify the most appropriate procedure. The most appropriate procedure. Okay? And then, next, we have to select the sample. So for example, if I'm working in a food and drug industry, and I want to check if this plant is effective in treating something. And so I would have to know which part of the plant should I use. Should I use the roots, the leaves, the stem? Okay? So you have to select the sample properly. And so you have to do research, of course. And then we have sample preparation. So if I use the roots, do I just grind it, or do I need to boil it, or do I do both, grind it and then boil it, or boil it and then grind it? So you have to think about how to prepare the sample in order to obtain the best answer, the most reliable. Okay? So next is the analytical procedure. Choosing the analytical procedure. So what should I use? Like, what instrument should I use, and what method should I use? Should I use a previously used method, or should I improvise the method? And if I improvise the method, will this method, do I think this method will be more effective? Okay? So that's what an analytical chemist does. Now, next is, of course, statistical analysis. This is very important. In every measurement, you need to have statistical analysis. And then, of course, data reporting. Because the statistical analysis, this will show how reliable your results are. Right? Okay. So let's say, for example, I work in like GMC, or General Milling Corporation, if you don't know. Um, and we have a delivery of salt, like a one truck of salt na delivery. Now, we have to define some terms first. So the salt is the material, okay? And then the whole truck of salt. So before it arrives, before we use the salt for production, we have to analyze if it's really real salt, right? Or if it's not mixed with other things. Because just to make sure, because this is what we call quality control. So we have to check if the salt is not adulterated, or if it's really salt, okay? So what we have to do is, of course, we have to analyze the truck. We have to analyze the salt in the truck, but we cannot analyze everything, right? Because if we analyze everything, then we won't have any salt left to use. So the salt inside a truck is what we call as the population. So that's the population that we need. This is the whole population, is the whole of the material, whose properties we need to we want to obtain, okay? And then the sample is a fraction of a population, of the population. So we just have to properly select which part of the salt inside the truck we have to obtain in order to test their properties, to confirm if it is indeed what we requested from the supplier. Okay? So to choose which part of the population we need to take samples of, that will be discussed later. So that's part of the sampling strategies, okay? So we have to understand the difference between population and sample first. And then after you get the sample, you also have a laboratory sample. So a laboratory sample, of course, it's sample that should be used in the lab. So actually, it's just the sample, but because the sample might be too large to be used for a specific procedure, because diba, in some procedures, it's they just say use 1 gram of blah blah blah, like that, right? So that 1 gram is what you call as the laboratory sample. So there are excess of the sample. So that 1 gram is what we call as the laboratory sample. Okay? So very important in sampling class is that this sample, very important, this sample should represent the whole population. So for example, in a one truck of salt, you can't just take samples nga duol sa door, right? You can take samples sa kilid, and then, okay? So actually, class, what in real industry, they usually their sacks man isud og sako, so they kanang stab the sack and then get samples from different parts, okay? But it depends on the sampling scheme, as long as it has to represent the whole population. Para makabalo ka nga, what if ang ilalom ra dayto ang gisambugan, di ba? Pareho ng bugas bang magsambug ang uban, so wata kabalo ang ilalom kay sinambugan niya ang babaw kay dili, so ikakuha nimo kung sa babaw ra ka mokuha og sample, then ang sample sa babaw, of course, sakto kayo kay wala mang gisambugan babaw, nara man sa ilalom niya, wa ka nagkuha og sample sa ilalom, di ba? So it's your results would be meaningless, useless already. So the sample has to represent the whole population. Okay. So we have different, so in for example in a wait in the food industry, for example, in the case of sa sampling plant sa food industry, they consider many things. Okay, so sampling plan, so this is the first part, right? Sampling plan. So one, they consider the purpose of the analysis Okay, so it depends on unsay imong purpose. There are different reasons man. So for example, if the purpose is for official samples, mao na ang like ihatag baron sa food and drug industry, I mean sa Department of Food and Drugs, Food and Drug Administration, Food and Drug Administration, yeah. Like ihatag, we need to, di ba kay namjo na yung mga i-comply nga requirements sa government, di ba? Para ma-approve ang imuhang mopasar ang imuhang food product. So you need to send official samples. So of course we need to check the legal requirements of the government laboratories, di ba? Like the company has to comply for public safety purposes, labeling sad sa products, okay? So that could be the purpose of the analysis. Another purpose could be for raw materials. So pareha tong sa example sa salt ganiha. So if wala ka pasar ang salt nga gihatod, then you have to return it to the supplier, right? You cannot use that. You cannot use that. Okay, next. Process control samples. Okay, these samples are often analyzed during processing. So for example, if ang kana nga sample is nagpass ra through a conveyor, like continuous nga production sa food ba, nagpass ra siya through a conveyor, so you take samples like maybe every 1 hour baron or every batch, if batch siya nga sampling, di ba? So that's what you call as process control samples, to know if wala ba nagka kanang dimao ang machine baron, or nabay nakuan sa machine in the middle of manufacturing, okay? And then finished products, we already know this. I mean, this is obvious. So, like for example, kanang mga namjunay tasting, di ba? Pareho ba nang mag-catering ka nga, magpa-taste pa gani ng uban before nila i-serve. Okay, so that's even part of the sampling plan. I mean, purpose sa ilang sampling plan. And then we also have for research and development, so R&D. Not all industries have this, but this is necessary for all. However, these are analyzed only for product development. Okay? Next that you have to consider for sampling plan is, aside from purpose of the analysis, you have to consider the nature of the measured property. So after you do this number one, kaning purpose of the analysis, you have to know what parameters must be measured in order to reach the desired purpose. So example ani kay, do you need to measure the color or the weight? So naadyoy para measure ani ha, color, weight, fat content, inana ba? Okay? So it depends on what you need to, I mean, it depends on your objective. Oh my god, where is it now? Okay. Next is we have to consider the nature of population in our sampling plan. Okay, so it is extremely important to clearly define the nature of the population from which samples are to be selected. So, for example, is it finite or infinite? Okay? Like, so, for example, a truck of salt, ang example sa finite is truck of salt kay nara magyud siya sud sa truck, di ba? Ang infinite kay if na ang salt is nag-agas-agas sa conveyor, nag-agi sa conveyor. So, di ba, wa ka kabaw when it stops, asa ang sugod ug asa ang end. Right? Okay, next. You have to consider this to do your sampling. And then if it is continuous or compartmentalized. So continuous, compartmentalized. Okay? So continuous, like for example, liquid milk or oil in a tanker, di ba? It's continuous kay kanang wala may separation. There's no separation from one molecule of liquid milk. Is it separated from another? Yan na ba? So, it's continuous, right? Compared sa compartmentalized. Like, for example, box of potato chips. Ang imuhang kuhaan og sample. So, it's compartmentalized. Kay gibox na gudaan, di ba? Okay. Next. Is it homogeneous or heterogeneous? So, for example, well-stirred nga oil in a tank. It's homogeneous, right? It's well-stirred. Heterogeneous, truck of potatoes. It's heterogeneous because not all the potatoes have the same size or have the same have the same look, have the same weight. Okay? It's heterogeneous. Okay, next. What we need to consider is I'm sorry. Okay. So the next thing that has to be considered is the nature of the test procedure. Oops. The nature of the test procedure. Okay? So for example, is the test, we have to consider if if the procedure is for example, if the procedure is kanang fast baron or is it sensitive, like maka-analyze ba siya og gamay kaayo nga amount, that's what you call as sensitive, kanang gamay ra kay nga amount ma-detect niya. Okay? And is it accurate, and is it labor intensive, or is it kanang we have to consider the cost of analysis. Okay, so we have to consider a lot of things. Next is and this is the last one, is developing a sampling plan. So this is the final thing to consider in sampling. So after you consider all those factors above, I mentioned all the other factors. So you have to consider the sampling plan. So for example, the sample size, of course, like how much do I need to get from the population. Okay, so it has to be you have to consider pod how big the population is, right? Ang variation pod sa properties sa population. So for example, if you are working sa environmental ang imong work, so for example, like you have to analyze the presence of a metal, a hazardous metal like chromium in a river, di ba? If you have to analyze a hazardous metal chromium in a river, then you have to consider kung sa kadaghan nga sample, and also sample location. So balik ta sa sample size. So, for example, chromium in a river, di ba? In river water. So, you have to consider nga, ting ulan ba? Ting init ba? So that you will know when to take samples. Di ba? And then next, sample location. Asa man ko magkuha? Dito ba ko dapit sa may bukid or nga river or dapit sa kanang city, kanang river nga city duol, kanang daghan og mga industry. Okay? So that's sample location. So, di ba, there are so many things to consider. So, sampling pa lang daan class, it really has to be kanang thought of rather. Okay, so we have sampling is kanang extremely important and sometimes, actually, oftentimes taken for granted by many researchers. So you have to think about how to devise this sampling plan. So it has to be, a sampling plan has to be very detailed and accurate. Okay, and okay, so we have kanang the types of sampling, different types of sampling. So we have types of sampling ha. Mao na ni akong gingon ninyo nga how you take samples. So first, we could have random sampling. Random sampling meaning kuha diri, kuha dito, something like that. Pero randomly, pero like for example, this is mao ni ang lugar sa imong area sa imong sampulan, no? Mao na ang whole area, whole location. So that's the map of ginahanglan sampulan. So ang random sampling is wala kay random. So kuha ko dere, 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 kuha ko dere. As long as it's still a representative of the whole population. So kini mao ni imong whole population. Okay? And this one is mao ni imong sampling sites. Okay? And then we have systematic sampling. Systematic sampling. Okay, so for example, systematic sampling, same nga location ane. Ang systematic sampling is like, for example, every 1 by 1 nga box. Every 1 meter by 1 meter, magkuha ko sa center. Every 1 meter by 1 meter. So that's a systematic sampling, right? Next, we have judgment sampling. Judgment sampling. Judgment sampling. So, it's basically judgment and experience of the analyst. Okay, so if may na kay ka, like pila na ka years ana nga nagbuhat, and then daghan na kay kag na conclude from your years of experience, then you can do judgment sampling. So for here, ang continuation na niya. So developing a sampling plan, you have to consider the sample size, sample location, and then you also have to consider, of course, the sample collection. Okay? So, unsaon ako, this will answer the questions like, how do I take the samples? Do I need to use mechanical sampling devices, or do I need to to do this manually? Like for example, magkukog soil sample. Kinahanglan ko mo gamit og PVC para circular jud akong sampling, or do I need to kanang bolo para ikauton ra nako and then isud sa akong ziploc bag, something like that. Okay? Now, so now that you have the samples, you can now do the preparation of lab samples, di ba? Kaya you have to take them to the lab for analysis. So the first thing that you need to do once you reach the lab is that you have to make the samples homogeneous. So make the samples homogeneous. So the samples are usually heterogeneous, di ba? Like for example, salt na uban, ang rock salt dagko kaayo uban, ang uban gagmay. So you have to make this samples homogeneous by for grinding. Okay? Next, in analysis, of course, we have to get several replicates, right? Daghang trials, daghang replicates. So we could do maybe 5 to 6 replicates, okay, para ma-confirm dyan mo if what you did, I mean, you're doing the correct steps or correct methods. And then you have to reduce the sample size because, of course, for example, in analysis, in a titration, for example, if you use too much of the acid, then dili niya kaigo ang 50 ml nga nasa burette nga base, di ba? Di kaigo, so you have to refill and then it will make more errors. So you have to reduce the sample size. Number 3, we have prevent changes. So prevent changes in a sample. So for example, in your river water sample, some other things present in the sample might react with your analyte. For example, it might react with the chromium. So then once you analyze the chromium, false na to siya nga result because some of the chromium have reacted before you even did the analysis, di ba? So you have to prevent changes in sample, like sometimes you add things, okay? So these changes actually include enzymatic inactivation. This is usually in food industry. And then lipid protection and microbial growth and contamination. These things are obvious, right? And contamination. So contamination. Okay. Now, next is the sample identification. This is basically labeling, okay? Very important. Do not neglect this, class. This is as important as every other procedure in a sampling plan. So this includes like sample description, okay? So, okay, later on in your analysis, nanyay kay ma-find out and then kulangan imuhang sample description. So your result might kanang dili rationalize sa imong result because the description is there's a missing description. Okay, wala na identify og tarong ang sample, right? So that's why sample identification is very important. So this also includes the time sample was taken, and then you have the location of the sample. Asa siya na take. Best to use kanang GPS, okay? Kay na-jud na siya sa map. And then person who took the sample, of course. Person who took the sample dapat na-jud na. And then the method used to take the sample, okay?